Hi, I'm Mark from Split Second, and today we're going in the lab with the VC3-100 Voltage Clamp. This is our newest voltage clamp product, and in this video we will actually see it in action on the test bench. And before going to the test bench, I'm going to talk a little bit about what this device is, what it can do for you, how it's connected, and how it works. To begin with, the voltage clamp can be looked at graphically. If we think about an input and an output, the input voltage, say 0 to 5 volts, for example, output voltage 0 to 5 volts, and if V out equals V in, say the voltage clamp is working in its linear range of operation, some input voltage describes some output voltage according to this 45-degree line. The way the voltage clamp works is it follows that until we break off, and we limit the output voltage even though the input voltage keeps rising. That's the clamp action. Let's say you have a modified engine with a turbo, and you've taken care of the fueling of the engine and the timing, and everything's good, you have boost control. But when you go into boost, you hit fuel cut. That's what this device can help you with. Say the map sensor reading gets so high that the ECU considers that out of range, and either to protect itself or because it's programmed to look for faults, it goes into fuel cut. And let's say fuel cut happens at 4.5 volts, which corresponds to some pressure on the sensor. Well, we could limit it to just slightly below 4.5 volts, let's say 4.3 for example, and then we follow the output of the map sensor until we hit 4.3, and then it holds there so that we don't actually go high enough to cause a fuel cut problem in the ECU. Now it turns out the VC3 is adjustable, so we can set this level anywhere we want. The high level can be adjusted from 2.5 to 5 volts when we're operating off of a 5 volt supply. And there's an internal adjustment you can make, and when you turn it clockwise, that increases the clamp level. There also is an adjustment for a minimum level, and as you turn that clockwise, that turns that up as well. So we can set a minimum and a maximum level so that when we go, say, 0 to 5 on the input, we might be able to just go 1 to 4 on the output, or however you want it to be. With a 5 volt supply, the VC3 automatically sets the low level adjustment range from 0 to 2.5, and the high level adjustment range from 2.5 to 5. Now it also turns out that the VC3 is just as comfortable working on a 12 volt supply, and when you just connect it to 12 volts on its power wire, this low level can be adjusted anywhere from 0 to 3.5 volts, and then the high level from 3.5 to 7. And that switches over automatically depending on how you have it connected. Speaking of connections, let's say we have an example of our sensor. Let's call it a map sensor, for example. And then let's say we have an ECU. And the map sensor, of course, provides intake manifold pressure information to the ECU. That's the signal wire carrying that 0 to 5 volt signal. There's also a ground, say, and power, and for a map sensor it's going to be 5 volts. So this is the stock map sensor configuration in an ECU. It's usually a 3-wire device, ground, which is a signal ground, a signal wire, and then the 5 volt supply. Let's say you've got a fuel cut issue. You want to use the VC3. You're going to put it here. You break the signal wire, and this is where our clamp goes. And so we cut the wire, we have in and out from our device, and then it does this. We also have power and ground to connect. Those are the 4 wires on the device. So this is V in, V out, and that's 0 volts or ground, and that's 5. And those are all the connections we need for the VC3. Notice that this is really like an extension of the map sensor. All of the wires that we connect to are the wires that go to the map sensor. This is very important because on late model ECUs, they can take sensor readings long after you've turned off the ignition on the vehicle. And in fact, for up to 30 minutes, ECUs can be polling sensors and taking readings. And we want to make sure that whenever the ECU is reading the map sensor, it's getting back the readings it's looking for. And that will happen in this configuration because any time the map sensor is powered up by the ECU, so is the VC3, and it will provide readings to the ECU. So this is a little overview. Let's now go into the lab and look at the VC3 in action. Here we are in the lab with the VC3-100 Voltage Clamp, and we are just going to hook it up and see what it does. We'll start with the black wire, which is ground. It's always a good idea to connect ground first, and remember that you should always be connecting ground to sensor ground. I'm using 5 volts on the red wire, which is as it would be with a map sensor application. I've got VN, a variable voltage source, here on my test box, and then I've got my output voltage here, which goes to this output reading voltmeter. So I can adjust the input with my box and read VN and V out, and they will track through the full operating range up to wherever the clamp is. It turns out the clamp voltage is preset at the factory at 4.8 volts. So here we are near 4.8, it's still tracking, but when I go above 4.8, it holds there. Now, you probably don't want to clamp it at 4.8. You probably want something else. And let's say you have a map sensor application and you know that you can't go above 4.5. And you don't have a test box like this. So what you can do is, in the field, temporarily disconnect your input from wherever it's going and connect it to the power wire. And now, since I put VN on the 5 volt wire, 5 volts is going in. And so we can take the back cover off, and inside there's these 2 potentiometers, and this is the lower clamp adjustment, this is the upper clamp adjustment, and if I turn this, I can turn the voltage down. Let's say you want it to be 4.5, you just set it to 4.5, now we're set. And you can then take off the input from the 5 volts and go back to your sensor, which I'm simulating here on my test box with this adjustment here. And I've got a voltage higher than my clamp, so it's stuck at clamp, and then when I go below it, it's tracking now. So it turns out you can do the same thing with the lower limit. You may want to set a lower limit on a signal that either it's going so low it's causing a problem, or maybe it's an inverted signal that has a voltage that decreases as load increases, and you want to set a lower limit. So you could temporarily connect your input wire to ground. I can do the same thing here with my test box by grounding using this knob here, and so my output is as far down as it can go, and now I can adjust it. And let's say you want it to be 0.5 volts. And that's just as low as you want it to go. Well, we set it there. And I return my test box to normal reading. And it's tracking, and as I go down, it continues to track. And then when I fall below 0.5, it holds at 0.5. Now, the other thing that the VC3 can do is operate off of a 12 volt supply, as you would if you had a mass flow sensor. And let's say we input some voltage above 5 volts, which could easily happen on a mass flow sensor in a forced induction application. It could go 5.5, 6, it could go to very high voltages. So again, if we were to temporarily connect our input wire to 12 volts, we could then adjust our clamp. And the other way you can do this is simply to adjust it in the application, just turning it down until you clear the fault from happening. And so again, 12 volt operation, I can turn down the high limit. Let's say 5.25 is as high as I want to go, and we adjust it there. And now we can lower our input. It's holding there until we fall below it, and it's tracking again. So there you go, a nice quick introduction to the VC3-100 Voltage Clamp, and I appreciate your time. Thanks for watching.